So I'm going to talk a bit about artist-driven workflows. Like a lot of what we saw today is driven by pipeline requirements. Like end goal is 10,000 models in a certain pipeline in a certain way. We have a little bit of different approach with Needle Engine, and that's what I'm going to talk about. So first a bit about me. I'm kind of between the worlds because I originally ran, or I'm still running, a brand agency. So dealing with client problems, like doing projects for basically a lot of your type of companies, getting things to a high quality, getting things into trade shows and museums and showcases, making nice renderings and that kind of stuff. And over time, it turned out that there's a big need for more ways to bring content in the front of people, to bring content to the web. And that's when we started Needle as kind of a new way of approaching content creation and of approaching how pipelines work. And as Max already mentioned, also, like when you are around the internet and all these kind of technologies, you'll probably run over some of my posts because I'm pretty active in the open source community. I'm contributing to a lot of the technologies that we already saw in action today. Like a lot of the presentations had model viewer in it. I was an early model viewer contributor, added things to 3JS, fixing stuff in Material X and so on. So getting pretty hands-on on all kind of problems related to rendering quality and interoperability. Because that's one of the big challenges also as we saw today, like at which point in the pipeline do you kind of branch out to different formats? Where do you start turning glTF into USDZ or vice versa? Some pipelines are totally different. And so I've been very active in getting all these things to talk to each other and making sure that things flow from A to B in a correct way. So, but yeah. Back to Needle Engine. So Needle Engine is basically a web runtime for bringing 3D content to the web, with a heavy focus on interactivity and building applications. Like a lot of what we saw today in terms of presentations revolves around creating 3D models. And then the interesting question is what happens next? Like some companies do have their own viewers, like, I don't know, IKEA or Obi, they have applications embedded on their websites that are already complete and they just need to be fed with models. But a lot of what's going on is experimentation. How do we actually bring 3D to the web? How do people interact with it? And so on. And this is kind of where we saw an opportunity to think in new ways. And basically saying, what we currently see as kind of responsive design on websites where you have small screens and you have large screens and so on, this is starting to extend into 3D with the advent of all these interesting VR devices, advent of AR and all these kind of things. People aren't just happy anymore looking at your shiny storefront website. They continuously have more of an expectation being able to jump into your website or your application or your models. So people have these devices at home and are looking for, hey, how can I view this now in my space, in my garden? How do I go from your nice store page to 3D? And we see this as kind of a continuum and an evolution of what is seen as a responsive website. And this is where 3D becomes very crucial because once you're in a spatial environment, you need all these 3D models, not just so people can rotate around them for a nice effect, but also because you want people to be present and to actually immerse with these. And so that's one of the core focuses of Needle, making sure that when you bring 3D to the web, you can cater to all these different platforms and audiences. You can build web applications that use 3D, but make it available in very intuitive form. And a bit of a primer from a lot of stuff that we saw already today. There are very diverse creative tools out there. There's DCC applications for creating the content, where people actually push around NURBS or polygons or whatever and make stuff. There's a bunch of engines that are real-time capable or are very good at ingesting and outputting assets. There's a bunch of platforms. I only have browsers here, but of course there are native platforms, there's Windows applications, whatever. The web just has turned out to be one of the places where people actually go today. Like there was a time, like 5 years ago, where you could make a one-off application for a car and say, this is in the app stores, people download it. That's not happening anymore today. Like nobody downloads an app for a one-off use case. People expect things to work on the web. And then people are building products with this. And they're not just building like 3D viewers and configurators. There's collaborative spaces, there's games, there's trade shows, interactive experiences, a lot of stuff moving to the web. And then there's two more categories that I didn't have nice images for, but there's like marketplaces that basically sit somewhere on the left side here on more content to build worlds and experiences with. And there's an entire category of like catalysts, like tools that sit somewhere in the middle here and try to make things possible that are hard. And like Rapid Compact is one of them that we saw today on being a catalyst for I have these high resolution, high quality assets, how do I get them into a different format? And it's often a hard problem to explain to people because you need to know so much about the pipeline and the process to actually understand why something like Rapid Compact is cool. Well, and it's a bit of a challenge that a lot of like what we heard about has. Explaining pipelines is hard. There's so many of them, which is interesting. Like one pipeline is you go from Blender, you make a glTF, you run it through Rapid Compact, you put it into Model Viewer, you display it on a browser, like, which is, I think, a pipeline we saw quite a bit today. Or you go from 3ds Max directly to USD, put it into Omniverse, present it to clients there. Or you go from Blender, make your FBX assets, put them into Unity, make a WebGL build. Or you have a library of 50,000 assets, you run some custom processing, and you need both glTF and USD to put on your marketplace. Or long pipelines, and this is actually interesting because this is what it ultimately boils down to, what all the others kind of do in an encapsulated way. You start with a software, you produce an interim format like glTF, you run it through a pipeline, you get another glTF. Like this is already hard to explain. Why do I need like two of those? Because one is the higher resolution one you get right off your engine. The other is optimized for a certain use case. Then you may build a React application, run that through Webpack, put it on the browser. Like this is a long pipeline for people to just go from, I want this 3D model or this asset in front of someone's eyes. And at Needle, we took that crazy idea on saying, what if we take this whole pipeline and build one opinionated version of it, where we say, we take all the best practices, we do everything right according to what we know, we do a lot of fixes to the ecosystem around, like to all the open source softwares and so on, to make this work. And to basically say, from all of these applications, we can go to glTF, we can run that through processing, we can pack your HTML page, and we can put it on a browser. And the interesting part is we built this in a way that we're basically intersecting here at specific points in the pipeline that are traditionally hard because you need to know so much. And we said, okay, these are the glue pieces kind of that we need to build to make it easy for people. And we make it easy to extend. So that when you say, actually, I don't want to use like glTF transform, I want to use Rapid Compact at this part of the pipeline, or Simply Gone, or I want to build my web app with something different. Then we want to make that easy. We want this to be very pluggable, basically. So, and some of the technical terms, like we heard a lot of technical terms already today on what that means. In practical terms, it means we have integrations into DCC application. So basically, there's a package for Unity, there's an add-on for Blender, there's an Omniverse integration, and so on, that make sure that what you're building there exports cleanly out to glTF. Like a lot of these have their exporters, but they all have like tiny problems, like we heard from Max today, for example, on how to convert things or not convert them. Then we have our bundling pipeline that tries to do everything right in terms of 3D. Like we're going to hear from Eric tomorrow about like textures. KTX2 is a texture format for compressing things. And we're doing that for textures, for meshes, We enable simplification, level of detail, all that kind of stuff that is necessary for kind of today's requirements of bringing like a gigabyte of cat data to the web. And we're using a very similar approach there to how web development workflows work today, where you're going from, you have your source data to a bundle that you're then deploying, which is optimal for a given use case. And then on top of that, we have a runtime, again using GLB, that is built on top of Three.js, supports WebXR, supports collaboration, all that kind of stuff that are basically building blocks that you may need if you're building applications today in the 3D space. And one thing we're bringing to the table, which I think is pretty unique, since we're doing this crazy attempt of spanning the entire pipeline, we can leverage formats like glTF with custom instructions for each of these steps in the pipeline. So basically, we're starting at the very front at the DCC integrations and allow you to mark up, for example, your textures and saying, okay, this texture needs to become an ETC1S texture, or this texture needs to become WebP because of this and that, or this mesh can survive like more simplification and so on. And we can put these pipeline instructions very early into the glTF so they become part of the file and they're actually bubbling through the pipeline and can be applied at these various steps. And we're putting runtime instructions into the data. So basically from your DCC, you can already say, this thing here, when I click it, something happens. Or I can play an animation on these and that events. And this is something that enables a very interesting pipeline where you have a lot of control over what happens on the interactive side, because we can pass through the data to this pipeline. We can also make it pretty fast, because once you have this kind of horizontal integration over the pipeline, you can cache a lot of things that are traditionally also hard. Like basically, whenever you're exporting something from 3ds Max, put it into Rapid Compact, you're exporting the full file again. So that is something that just happens because there's kind of boundaries between these softwares. So what we can do here is we can cache stuff and make it much easier. It's also pretty easy to make some of these steps optional to run them in the cloud. Like what we saw today, is it like, can we compress assets on the cloud instead of having people to do that locally, or having to know how to do it, or having to know about all these formats. So there's some interesting options enabled by that. Oh, and what's also interesting is that we built this in a way that it's easy to kind of jump in and out of the pipeline at specific points here. So we have some clients that basically say, wow, your glTF export is so good, we don't need to think about it anymore, but we're only using that. Like we have our own simplification pipelines, we have our own pipelines to bring stuff into a viewer, but this is good. We have others that say, we have our library of assets, and we want this to run through your pipeline to get kind of web-ready, super efficient files out of it. And so this was kind of one of the core design points on saying, we're building everything around glTF as an open format, so that you can break in and out of the pipeline. So now it gets interesting, because we heard a lot of technical things today, and I'm also talking about long technical pipelines. What we ultimately want is that from a creator's pipeline, it looks like this. So I want to be able to forget about glTF and USD and formats and FBX and whatever. I want to be able to see my file in the production environment as soon as possible. Like that would eliminate a huge chunk of the problems that we have today in pipelines, where basically people are exporting files, and then at the end of a long process, they kind of see that something is not right, something's not rendering correctly, and so on. And so this is where we want to get. This is what we want to enable. And we achieved that, which I think is pretty interesting, that we can basically go from any of these softwares to a local preview in your browser that is the end of the pipeline in 1 second. So it depends on the meshes, of course, but due to like the caching we can do and all that kind of stuff, you get this kind of iteration speed from your digital content creation, from someone working on a 3D model, to the browser in kind of the final environment. This asset will be seen by someone. So all these kind of problems on I used incompatible materials, or I did something in the setup incorrectly, or whatever. These are eliminated very early on because people immediately see what the output's going to be. So, and then you can deploy this, bring this to the web, passing it kind of through more of the compression pipeline and so on. And this is also something pretty quick. Like those of you who may have Unity development experience, bringing something from Unity to the web is something that takes 15, 20 minutes for one iteration cycle. And we can do a full deployment to like a cloud backend here in 10 seconds, 2 minutes for most assets. Oh, and then it works everywhere. And this is, I think, an interesting aspect. Due to the way we've constructed this, we can make these assets run and these applications that people build on desktops, on phones, on WebXR devices, and even on iOS AR. And we have a bit of a different approach there. We're converting the glTF to use the on-the-fly, on-device. So a bit different. In a lot of cases, this is done as a pipeline step. You are taking a source model and you're producing separate assets. And we said, since we're collaborating so much on these formats and open source and so on, we can actually get this to work. Like we can actually get correct conversions from glTF to USDZ on the fly. And for consumers, it's great because they don't need to download a separate file. So things get faster, way to AR gets shorter, and so on. So I have a list here of like some of the wins that we're seeing from that already, because people need to think about less of this entire technology stack and can instead choose to what kind of pieces of that do they do a deep dive in and learn more about. Like I already talked about, seeing final results immediately. Things like light baking that are currently like very non-standardized. For most people, they just work because they can basically use light baking in Blender or Unity or whatever, and we make it pass out as nice glTF. We did a lot of work to get rendering and lighting to parity, so what you see in your Blender viewport or your Unity scene is exactly what you're getting on the web. And this is a big one. This need to fight with formats is severely reduced. Like we have some clients that we're working in for months now, and we had a recent call with, and they said, can we do this and that? And I said, sure, you can. This is part of glTF. And they were like, what's glTF? I haven't used this. So, and for me, that's a crazy win, because it means we're at a part where you can forget about these formats. Like the standardization has reached a point where a lot of stuff that you expect to work just works, and where you can like go from creative idea and creative vision to a browser and show that to millions of people in a very short time. Yeah, and a big thing for us was the kind of freedom to bring your own code and your own runtime and not be locked into a specific platform. Because we saw that a lot, that there's a lot of platforms like appearing that say, we want to be the sink for your data. Like we want to be where your data ends up. And it's like Omniverse, Spatial, and these kind of applications that basically say, we give you limited building power, but we handle the rest. And then we saw time and again kind of people working with that and hitting limitations, like you can't build a garden configurator in Spatial. Like you're just hitting limitations of what this software allows you. And this is something we wanted to absolutely rule out. Like we wanted to give you full freedom to build your own applications. So these are some of the wins that I mentioned earlier on, like the pipeline instructions, being able to pass through the pipeline what you intend to happen with assets for a given use case. Like basically already giving the artist control over this kind of texture is important, this texture is less important, optimize this in that way, and so on. It needs a bit of training, but we found that people are then much more efficient than an automatic pipeline later on making the decisions for them in terms of like quality of assets. Yeah, and on the runtime side, I already mentioned like we can convert to USDZ on the fly. You can bring a physics simulation from Blender or Unity to the runtime without even thinking about that. You can mark content up for, like, this is important for AR, this is important for VR, and this all happens kind of at an artistic choice level and not kind of at a later stage. Yeah, just some snapshots from how it looks. Like, this is a Unity interface. You're basically adding components to objects. You're not even thinking much about that you're working with glTF here or anything, and you can export this to the web. We have a Blender integration. We have Omniverse integration. This is maybe also interesting for a lot of you that are working with various softwares and tools. I can only encourage you to report bugs wherever you find them. Like, bigger part of my day that I would want is reporting bugs to all these companies and saying, you know, when you do this and that in your software, it comes out wrong or it looks wrong. And too many people don't do this because they think surely someone else has run into this problem. And so I can just emphasize, please do that, please report bugs. So, and lastly, I want to talk about a little bit about prototyping work. Like, we're always looking at how can we make creation easier and faster and make it easier for people to build stuff. So we heard this presentation about nerves earlier today. Like, one variant of that is Gaussian splatting that allows you to kind of render point clouds of complex scenes with complex lighting effects. And so we're also looking at, can we like vertically integrate that and give people tools to work with that, similar to how they would work with 3D assets. We're also looking at USD as an alternative of glTF for kind of the entire vertical pipeline. There's interesting implications when doing that, like some things get easier, some things get harder. Ultimately, I would say these formats are on a good level of similarity by now that you can build complex pipelines around them either way. So, and we're looking into a better automatic optimization, like we're doing some on our own, mostly around simplification and so on. But making it easier to, like, for example, integrate rapid compact or so on is interesting. So, and I think since I did so much theory stuff, I do want to show a little bit about examples of this. Just to give you a little bit of an overview over kind of the range that people are starting to build with this, I think that's interesting to see. There's a bunch of like these are our samples on what we put out for people to kind of follow by example and use. And these samples are mostly driven by kind of the creativity of what people start building once you take these limitations of formats away and just say, you know, there's a button you can click to bring this to the web. So there's some configurators, there's people are building architectural visualizations, little games, sandboxes where you can like put stuff together and collaborate, jewelry renderings and all kind of stuff. So it's interesting to see once like these, I mean, I'm a huge fan of these kind of formats and dabbling in technicalities and getting things right. But taking them away is an interesting approach to teaching people about 3D, to teaching people about pipelines, and kind of bringing back what they need to know to realize a creative vision. And yeah, I think that's what I wanted to show today in terms of a different approach to pipelines, like a more modular one, a more end-to-end one, that allows people to forget about a lot of these complex pieces and start creating. And with that, thank you.